He's Jeff.
And he's Michael.
And that's totally corny. Oh, look at that.
How you doing, Michael?
Good to see you, Jeff Z.
Hey, that's me, man.
Reasons to believe. Good to see you, my friend.
It is good to see you too, Michael.
It's Jeff and Mike back in action.
There we go.
All right. You want to get caught up on everybody out there. Hello. This is the chat session, and we're doing a new segment. We're introducing a new segment into our lineup. Normally, Jeff, on Fridays, I have a co-host, a guy named he calls himself Constitution Vet. He's a high school history teacher and and he's a vet. And we talk about all kinds of stuff. And I'm like, I got to get Jeff in here. I gotta get back to Jeff and Mike. I'm like, I cannot be doing this without bringing my astrophysicist friend on. So, okay, do you call yourself a physicist, or are you a physicist or an astrophysicist?
Little bit of both. So my bachelor's is in physics, my PhD is in astrophysics. So I've got both there. I de-emphasize the astronomy part because most people, when they think of astronomy, it's like, okay, you know where things are in the sky, can run telescopes and stuff like that. And I am not that, you go set me up a telescope and say, hey, find this constellation. I may or may not be able to do that. I've picked up a little bit, but I know a lot about how the physics works and how to get data from a telescope and do something interesting. So,
got it. So you're an astrophysicist, emphasis on physicist.
Correct.
with a minor in astro.
That is correct.
Well, it's still an impressive title. Now, so you actually work on a government grant, right? You have been funded by the government, or at least one day a week. Is that correct?
I have, yes. All of the research that I've done from Iowa State to UC Riverside to UCLA, all of that work has been government funded at a fairly substantial level. So,
and the best part is you also love Jesus.
Absolutely.
So the way I kind of look at it is you get to explore God's creation in more detail than the rest of us.
That's a great way to put it, Mike. I mean, I get to look at things. I was giving a talk the other day, and I was talking about the dark matter experiment I'm working on, and somebody, it just dawned on me. I get to do some really cool stuff. I mean, I get to look at black holes and gamma rays and dark matter and neutron. I mean, it's just I kind of get to play around for a living at some level, and that's really a lot of fun. So,
well, so you say you get to look at dark matter. So, what is it? You're looking at it all day long, every day. What is this stuff?
Well, we're searching for it. I'm not saying we're going to look at it. We're not looking at it yet. It's something. There's this stuff that just pervades the universe that has mass, has gravitational attraction. We can measure that and have done that on all sorts of different scales and different instruments. But we think it's a particle of some sort. And the real big question is, what kind of particle is it? Is it a massive particle that weakly interacts? Is it a much smaller mass particle that weakly interacts? That's the big question. And we're building an instrument that if we find a few particles of this other particle, that'll tell us, we know what the dark matter is now, which probably, if that succeeds after some verification by some other instruments, the guy that I work for, the head of the project, would get a Nobel Prize. It's that level of discovery it would be. So.
All right. So people here watching the chat session, watching this special, we're going to have you once a month, right? Just so people know, Jeff, the astrophysicist, the dark matter researcher, working on a government grant in a laboratory. Can we say where your laboratory is?
I work at UCLA, yeah.
And so you go at least
nothing secret about it. So.
Right. Okay, good. Once a week, you're in a laboratory at UCLA. So I've been to this laboratory, and it's in the basement of one of the buildings. And are you always by yourself when you go there?
No, actually, we've got a lot of people working down there right now because our balloon is supposed to fly in 2023, December 2023, and down in Antarctica because that's where it's summer down there. And so we've got a bunch of people in the lab doing various things. We're testing pieces, putting pieces together, keeping track of them all. So there's our lab is a hubbub of activity compared to when you were there. I think it was basically you and I. So
yeah, so that was the impression I had. I'm like, wait, you come in here and you work by yourself on the most like Nobel Prize level, right? Like you're at that level, and it's just this dark little laboratory in the basement of an nondescript building on the university campus, and you by yourself. No, I know there's a huge team, and it's a global team, right? I mean, you have team members. How many countries are your team members in?
I can't count the countries, but I know we have Italy. I know we have Japan. I know we have Lithuania. Yeah, I mean, so yeah, it is really an international collaboration of people working on this instrument.
And we're going to get to our topic here in a second. I'm just, interviewing you for the audience that may not know these details, and maybe they don't care. We'll get past this, but success means what? Right? You're sending a balloon up with very sensitive instrumentation up into the atmosphere to do some readings and see, if you're going to catch something, if that's that's the right phraseology.
Right.
And what would determine success for this project, and what would the ramifications or implications be?
Well, I mean, success would be our instrument flies and works to the specifications we've designed. If we do that, we're going to find something interesting. Now, the really interesting thing would be, we actually find dark matter. That would be cool. But even if we don't, we have now observed in a region of parameter space, is what the scientists will call it, where, if there's this map of all the different things that dark matter could be, you want to try and investigate all of those. And we will have investigated part of that and said, no, this is not it. So we will have narrowed down the field of what dark matter could be if we don't find it. And if we do find it, well, that's just too cool for words.
Yes. And it will send reverberations through the scientific community, et cetera. All right.
Well, what it will do is it will say, all right, now that we know what it is, instead of building these kind of general instruments that can survey a lot of different stuff, it's like, okay, we know this is what it is. We can build dedicated instruments that can detect it very sensitively, very quickly, and get a lot more information from it. So
your research will get more efficient.
Yeah.
Yeah.
Right.
So to tie this into what I want to talk about, somebody on the team had to put together a pitch or a proposal to get a grant, right? To get the money.
Mm-hmm.
And so the things that you just described, we're all a part of that. It's like, here's what we're wanting to do, and here's what we hope to do, and here's how we propose to do it, and here's how much it'll cost. We propose, blah, blah, blah. And then somebody, since it's international, but this is what department is the grant from? Right. And
this particular grant for the people who are in the United States and working is from NASA. So it's a NASA funded grant. There are other funding agencies in the federal government. I mean, the federal government recognizes that research into fundamental or, just basic research is beneficial not only in our body of knowledge that we build, but that also leads to advances in technologies. Probably why we're able to have this call here today was ultimately related to some sort of government research, because you got people who are far away and want to be able to communicate, and somebody came up, hey, we could try this. And, so there's a lot of after effects, whether we ever find dark matter or not, or many of the missions, what we develop, the tools we develop to try and look for them also often have peripheral advantages to society as well. So there's a lot that goes into that. But.
Got it. All right. So now I want to, the thumbnail, the title of this session, follow the science, right? Follow the science. We hear that phrase actually in our public discourse today more than maybe we've heard in recent years. And, it's related to, virology, right? One of the ways we hear that is virology and climatology, right? Environmental sciences, et cetera. We hear that, but we're not so much hearing it from a bunch of scientists up there saying it. We're hearing it from other types of figures, like political figures. And in some of the research I've done, or in some of the, research, YouTube channels or videos that I've listened to, it seems like there could be a tendency for the science to be obscured by political influence. When you hear the phrase "follow the science," I mean, you know what I'm talking about, right? When you hear the phrase "follow the science," what does that mean to you as a scientist? And
Well, yeah, that's a good question. And one of the challenges is there's a very good part of that, and then I think a negative connotation to that is, the reason why you follow the science is that what the data says, what the scientists learn, that gives you insight into how things actually work. And one of the things I love about science is that anybody can have their ideas about what might be the explanation, but just because you've got a beautiful idea or even a powerful idea, or you've got the biggest bully stick or bully pulpit, what ultimately matters is, does that correspond to the way the world works? Does it match future observations? Does it continue to explain? Does it have more? So there's this tool. It's a tool for finding truth. And that follow the science is, hey, don't let your ideas, don't let your biases, what your preferences, what you want to be, don't let that rule. Follow what the data says. And I think that's a great instructive way to do things. The negative side of that is that over the last few years in particular is where I've heard this. I mean, I don't know how, I can't say that it just started a couple years ago, but it became far more prevalent, is that follow the science became conflated with policies that are based on science rather than the science itself. So, for example, the obvious place where this showed up was COVID. There were, when COVID happened, there was just a lack of data on what was going on. So people were investigating, trying to figure out what was going on. But there did seem to be this follow the science as a way to get people to conform to what the policy decisions were. And in my assessment, people could understand the science and think, hey, there's different policy. You could agree on the science and have vastly different policies that you think would be effective in taking care of it. And that line got blurred. And I think that's very detrimental for science and for our society, because it diminishes the perception of diminishes people's perceived objectivity of science, and it makes science political. And neither one of those, I think, are a particularly good thing.
So, Mom's asking a question here. By the way, Bonnie here is my mom, and we do a show on Wednesday called Miracle Mom and Michael, and Mom is a survivor of a couple of near-death experiences, and she loves listening to you. So she has a question for you. Question for Jeff: is science today merging with the occult? I don't know if we need to address this.
Well, I'm trying to figure out what exactly that question means. That could mean many things. I think science today is as science has operated for the last 300 or 400 years. It's people arguing about what projects are important to do, what experiments do we do to validate this way of looking at it or falsify that way of looking at it. I do think with the way science operates is largely unchanged. I think my suspicion is, and this is Jeff ZWEERINK's thoughts, I don't know that I can't point to any research that backs this up, but as the Judeo-Christian worldview has been undermined, people are going to replace that with other worldviews, and the occultic, more superstitious type worldviews, those are going to become a more prevalent part of just people in general, and that's going to flow into the science, because science is done by people. And so whatever your population thinks, that's going to flow into the way scientists think at some level.
Good answer. Good answer, and I'm glad you answered it, and I didn't go off on my mom. But that is right. Like the occult, what is that? Is people delving into the supernatural outside of the parameters that God has preordained, right? There are supernatural forces, right? God is not a physical entity, and we are in the image of God. And so there is the dualistic nature of human, substance dualism, right? We are both a physical substance and a non-physical substance, according to J.P. Moreland, right? And so, yes, there's stuff going on out there, and when you try to access that, like get information or communicate with the dead or powers or spirits, etc., that's outside of the parameters that God ordains, and the parameters that God ordains are in the 66 books of the inspired Word of God. But getting back kind of to this topic, so you're saying that policy, and it's my understanding, yes. So governments try to build policy, they try to build good policy to trying to help humans live harmoniously together and take advantage of, the knowledge that science provides toward that end. However, when you have people, again, we are all humans, right? Scientists are humans and politicians are humans, and they can have agendas, and they can either be led by money in a direction and skew data to support that, right? They can cherry pick scientific data to support. For example, you hear this 97% of scientists agree, right? And by using that number, throwing out 97% of scientists agree, that's supposed to be an example of following science. And but if it's a poll of scientists, don't you need more information? What were the questions asked in the poll? What kind of scientists or who exactly answered, right? There's a lot more to it. But if you throw out a number, that helps a politician communicate an agenda that may actually not be supported by the science, but they have a number they can use to promote their policy. I mean, do you see that? I mean, as an astrophysicist, I don't know if dark matter is in that realm. If people have an agenda to, find dark matter for some nefarious agenda, but there are people with agendas like climate agendas or virology or control or whatever. Have you seen, or do you have examples of what I'm talking about? Is it registering with you?
Well, yeah, it does. And I, the immediate idea that came to mind is I remember watching kids, and it was like 4 out of 5 dentists recommend, and I can't remember, I think it was Colgate was the brand of toothpaste. I'm going to get my royalties from that plug there for them. But it was just, I remember that sort of data has been out there. I think, to me, what is the larger problem in that, or the place where that gets muddier and more difficult to deal with, is science isn't done by consensus. Some of the greatest ideas, the most prominent, the ideas that we now think, oh yeah, that's the way things work, they were all minority positions at some point in time. And so, whether something is a lot of scientists or a few scientists, especially in those areas where the data isn't abundantly clear, you can make, statistics can make anything look anything, or make anything look true. You can make anything look good with statistics. There's a polite way of saying the way that phrase goes. But what gets muddied in that is the way I would characterize it is, I'm old enough. There was commercials about E.F. Hutton, and people would be all out there talking, and well, my broker's E.F. Hutton, and E.F. Hutton says, and everybody gets quiet and listens. Exactly, yeah. Well, science has that kind of E.F. Hutton. Well, E.F. Hutton, because they had the authority, they did well. People wanted to know what it had to say. Well, science has that kind of objective. This is the way things are. I want to listen to it. And where we start using that for other means, we diminish its credibility, or we diminish the capital that it's built. And, your comment there, almost everybody has an agenda. And when you start mixing the agenda with the science in the public perception, that becomes hard. Now, the reality of it is that happens among scientists all the time. That one of the things that I think or most of the public saw was just, this is in all of the what's COVID? How does it spread? How dangerous is it? All of that data, do masks help? There's a whole lot of that where scientists are kind of getting the data in real time, trying to understand. And this is the sort of debate and discussion we have all the time. It just normally happens. Nobody cares about the discussion. They kind of care about the end results after it's well established. This was one particular arena where the public got to see how the process works. And I think the process actually worked very well. I mean, we know a whole lot more about COVID, how it spread, what it works, what works it to work or to mitigate the disease. We know a whole lot more now because the science actually worked and the scientific process worked. But it did get muddied with, or it kind of sullied a little bit because people thought, wow, that's a really messy thing. And scientists really don't know. And they're political, and that it got all kind of clouded in there. And I think that, again, diminished the credibility of science in a lot of people, somewhat unnecessarily, because that's the way science typically works, somewhat necessarily because people used it for political advantage or to drive things that are not really scientific issues.
Like making government policy based on, right? Making government policy based on one interpretation, right, of a set of data, right? For example,
I'll give you an example that just goes to that. So when COVID first came out, you know, you had a decision point here. It's this disease. It's a highly contagious disease. That was known. It's worse than the flu. That was pretty well known. But now you have this choice. You've got this disease that is highly contagious and is going to cause a lot of people to die. Now that's what we knew. Now you could go with a couple of different policies. One policy would say, all right, we need to do whatever we can to slow the spread of this disease. And just recognize that in doing that, that's going to have economic and other consequences. Or you could say, you know what, this disease spreads so rapidly, there's virtually nothing we can do. What can we do to help people be more healthy and to have the infrastructure to rebuild and help those who are dead? Both of those recognize the science, but they're two very different policies. I mean, I could make an argument for each policy, and I actually suspect that latter policy would have had fewer casualties to it in the long run. Now, that's a policy decision, not a science decision. The data would have to support that. But we both would agree on the science. We're just arguing different policies. But so I think that's an example of what you're talking about.
Yeah, that's actually a perfect example. And you did a good job not getting us deleted from YouTube. Right. And that's the craziness of this, is there becomes a narrative that becomes the official narrative. Right. Mm-hmm. And they say we're following the science, and that bringing us back. I'm like, actually, no, you're following something in addition to the science, or built on top of science that, you know, it's not science. You're not following the science. You're following a policy decision purportedly based on the science. And as you said, yes, the science has shown us, you know, what this new thing that's been introduced into the human species, right? It's like, mm-hmm. Now it's with us forever, right? Arguably, it's like, you're not going to eradicate it. It's not going away. And that's, I think, where the policy decisions were, the policy decisions were misguided in looking at the defeatability, right? It's like the common cold is still here. You haven't solved that. Isn't the common cold a COVID, right? Isn't it? Yeah, it's a coronavirus.
I don't know. I am a little sympathetic to the position, though, that if you could have organized the population properly, and I think it would have been we would have needed to take more dramatic measures than what we did. There is this possibility that you could have said, okay, it runs its course in a few people and it goes away. I think that was a reasonable thought to have there. I just, given the way we've handled other diseases, there are other diseases that we could eradicate in the population in a generation at the worst. And yet we either don't want to or can't organize enough people to say, yeah, we're going to handle that. So there's the science of what goes on, but then there's the way people behave. And both of those are mixed up in whatever policy you do.
Yeah, I think one of the probably everything's hindsight is 2020 and looking
Right.
back in retrospect, right? So looking back, the people that were most affected, right? That's how the radical change in our culture should have happened, is to concentrate on the people who were most susceptible and most affected, and that's people with comorbidities of a certain age, right? And sure, there were people of all ages that died, but the vast majority of people who succumbed to the COVID virus were comorbidities. In fact, the papers or studies that I recall, it was multiple comorbidities. The vast majority had more than just one. It was multiple comorbidities, and the average age of death was like 79 years old of COVID patients, and the average death without it is 78. I was like, it's killing people that are dying. Essentially, it was targeting people that were already on their deathbed. Anyway, but I do want to just, in these last couple minutes, veer toward another topic that you and I have talked about a little bit. I'm going to ask you a question that I've asked before. If and when both polar ice caps melt, how high will the sea levels rise?
Oh boy. I don't actually have that information off the top of my head. I know historically in the past, so I did a brief talk about Bermuda, and right now I think there are like 100 islands in Bermuda. But when the glaciers and the polar ice caps grow large, there's a lot more islands because the sea level goes down. And when the sea level melts, most of Bermuda disappears. And so I think it's on the order of tens of meters that it would go up. But I hopefully I've given enough caveats that nobody goes in, he doesn't know what he's talking about. I can tell you right now, I don't know the number off the top of my head, but I do think it's a substantial amount of sea level rise. Like I said, tens of meters.
From talking to you and from hearing or listening to other sources, it's somewhere around like the Statue of Liberty will be like ankle deep. Okay. Something like that, right? So it's 10 to 15 meters.
Something right. Well, that's almost 2 tens of meters, so I was right there.
Yeah, you're in the ballpark. It's not Waterworld with Kevin Costner, right? It's not, we're all going to be submerged by there's not enough H2O on the planet,
right,
to cover the surface of the Earth. And so it's this fear mongering that even if, and I mean, is it true that this blue ball that we live on in the past has existed without polar ice caps?
Yeah, there have been, in fact, well, I know even if you just restrict yourself to the last million years where we've been in this ice age cycle, there are lots of times, there's long glacier periods, there's these interglacials, which last for a while. But during the interglacials, you almost always get the polar ice caps melting, or at least substantially melting. And so, yes, that is, one of the things that's true of the history of the Earth is that it gets as cold as it can get and as warm as it can get, which is about a 20 degrees Celsius window, which is remarkable when you think about it. It's only a 20 degrees Celsius window. But yeah, it gets as cold as it can get and as hot as it can get, and it's done that multiple times throughout the history. And even within the history of the last few million years, it's done things like that.
And so it's nothing to be afraid of, right? It's just something that happens and the environment can handle it. So is there a benefit to having more H2O or more, I mean, would there be more water in the atmosphere as well? We have under a minute left for this question.
Yeah, I don't think you're going to get more water in the atmosphere because there's already a lot of oceans. The question is, how quickly does the climate change? And I think that does cause problems. So I agree it's not something to worry about, but it is something that we need to prepare for because it will have some consequences. There are lots of islands that may just disappear. And so I don't want to be callous and say, we just don't have to worry about it. But it's something we can handle if we prepare and take care of the people in the world.
and it takes place over a long period of time. And human innovation and infrastructure, you either migrate and move out of those areas that will be most affected, but it takes a long time. I mean, the melting and the rising is like centuries. It's not suddenly, right? It's not going to happen suddenly. And we migrate out of the affected places, or we build up whatever. All right. It's good to see you.
It's a little hard to move New York, though, because there's got a lot of buildings there. So.
They can build seawalls, whatever. All right. Love you, Jeff. And for those of you who don't know, Jeff and I have a channel. I mean, I've put stuff on the channel. It's Jeff and Mike. If you want more of us talking, go to Jeff and Mike on YouTube and see a bunch of the videos we posted there. All right. I'll see you in about a month, Jeff. We got to go.
Sounds good, Mike.